In this video, I'm going to show you how this hyperspectral scanner works. The system has two components. One is the hyperspectral camera in the center here. The other component is the scanner itself. The scanner has a movable platform underneath, and it also has two sets of halogen lamps. Here's one set, here's the other set. These two components are controlled by the computer separately. For the hyperspectral camera, is connected to the computer via the Ethernet cable here. And here's the power cord going to the camera. The scanner bed has its own power cord and is connected to the computer via a serial cable. So here's the lens of the hyperspectral camera. Here, this is where you adjust the focus. I have focused the lens already, so I'm not going to touch it. And right now the lens is pointing downward. And how this type of push broom hyperspectral camera works is that it scans one line of image at a time. So the line is oriented this way. So in order to have a 2D image, we'll need to move the object underneath the camera lens. And then we collect multiple lines of the object, and then we combine those lines to form an image. So I have printed on a piece of paper a black circle. So I'm going to start the scanner. Okay, now it's going to start scanning. It will first accelerate and move to the position I set at, and once it reaches there, it will slow down to the speed I specified. The reason I'm scanning this circle is because for a specific frame rate that the camera is acquiring the lines at, that's how many lines per second it scans, we'll need to have a specific speed for the platform. If the platform moves too fast underneath the camera, then the circle will end up squished in the scanning direction. So it will be squished by this way. And if the platform moves too slow, then the circle will be elongated. And then so that's why I'm scanning the circle to adjust, to find out like what's the best speed to have a square aspect ratio for the pixel. So the platform speed depends not only on the frame rate of the camera, but also depends on the height or the distance between the camera lens and the object. So the camera can be adjusted in terms of height. So it's mounted on this aluminum frame, and we can lower it if we want to. And also, if we have an object that's sitting higher up or closer to the camera lens, we will need to have the platform move slower in order to have a square pixel. That's because when the object is closer to the lens, then the field of view in this cross section is actually smaller. So we'll need to slow down the platform as well to make a square pixel. Okay, so here you can see that once it finishes scanning, it returns the platform back to its original position. And then so that's how this camera scanner works.